will cover section 4.3. We're probably just going to get through a couple of slides. We only have 10 minutes. So the section we will finish it on Friday in class. Now, what we're going to do now is we're going to go from the unit circle and translate that into triangles, okay? So that we can be comparing the ratios. Now, we started with the unit circle because the equation, it just works really nicely, and you will get the correct values for your trigonometric identities. However, there's a way that I'm going to show you with triangles. But for this one, I want you to consider the following. The definition of sine is going to be the ratio between the opposite side and the hypotenuse, right here. Opposite side of the ratio of the opposite side and the hypotenuse. So if we were to consider this angle, which is in standard position, the vertex is at the origin, the initial side is the positive x-axis, this one is the terminal side, the angle is positive because it goes in that direction, and it is pi over 3. And pi over 3 is equivalent to 60 degrees, okay? You can see that. So for that triangle, if we were to draw, for that angle, if we were to draw a triangle here, because the x and y coordinates of this point, we could also find them as the vertical distance, that will be y, and the horizontal distance, that will be x. Correct? Yes? So that is what we have here on the next drawing, the y and the x. Now, we use the unit circle because, of course, the radius is a 1. So what I'm going to say here is that this is a right triangle, and so therefore the hypotenuse is 1. Now, when we talk about ratios and we want to divide the opposite side by the hypotenuse, what we're actually doing is, for this angle, the opposite side, the angle is here, okay? So the opposite side to that angle will be right across from it, right here. So that will be y. And the hypotenuse is equal to what? 1. So if you notice, that's what they are showing us here. All right? Now, if it is true for the unit circle, then it is true for any triangle. Okay, let me show you something quickly. Have you guys heard the term concentric circles? I was drawing some of those the other day with the carousel problem. So what is in Spanish, con? What does that mean? C-O-N, with. So it's with the same center, concentric. Okay. So the idea here with the unit circle is that if it works for a triangle of hypotenuse 1, it will also work for a triangle with hypotenuse 2, or hypotenuse 3, or hypotenuse whatever you want, okay? And I will show you that with triangles in a minute. Now, let's go to the definition of cosine. Cosine, we were used to just seeing x, right? But it was just x because the hypotenuse, or the radius of that circle, was a 1. But in reality, the cosine is the ratio of the adjacent side, so adjacent, divided by the hypotenuse. Again, the ratio. So the adjacent side to this angle, I will point it out to you with this triangle here. The adjacent side to this angle is going to be one of the sides that makes the angle. And it's not the hypotenuse. So which one do we have left? The bottom one. The one on the x-axis. Adjacent, right here. Okay, that's what it means. Adjacent is adjacent right next to the angle. It actually forms the angle. Opposite is right across, like if you were to shoot something, that's opposite. Adjacent, it forms the angle. Okay? So the adjacent in this case is x, and the hypotenuse, we already said it was 1. Okay, so the reason that we were just using x and y is only because the radius was 1. Okay? Now we're going to consider opposite over hypotenuse, adjacent over hypotenuse. Okay, so you guys ready to see it with triangles? Yes? Ready or not? Okay, so we have here different triangles, 4 different triangles. However, they are not congruent, but they are similar. Yes, they are similar. Because they have the same angles. How do I know that? Well, first of all of them have a 90-degree angle, right? Yes, you see that? All of them. And all of them have theta. I don't know what theta is. I don't really care. But if we're assigning the same variable, that's because they measure the same. And so, isn't it true that all triangles add up to 180 degrees, the interior angles? So what that means is that by default, if we have 180, if we subtract theta, and then we subtract 90, then we're obviously going to have the same angle, right? So what that means is that this angle is the same as this, same as this, and same as this. And so we could say that the triangles are similar. They have the same angles, and they're not congruent because obviously the sides are not the same. However, we're going to see that they are proportional. All right? So let's see. To find the tangent, do you remember how tangent was defined as sine over cosine? Yeah, do you guys remember that? Okay. What is sine in terms of opposite adjacent? I just gave you the answer. Sine is opposite over, hypotenuse. Anytime you catch me making a mistake, let me know right away, okay? Opposite over hypotenuse. What was cosine? So let's say I want to apply sandwich rule here. It's almost lunchtime. So we'll have opposite times the hypotenuse divided by adjacent times the hypotenuse, and then maybe the hypotenuse over the hypotenuse cancels out, right? Yes. And then what do we have left? Opposite over adjacent. So that is the notion we're going to use for tangent, okay? Opposite over adjacent, or y over x. Okay, so going back to these little triangles that we see here, we have here the tangent of this angle, of angle theta, and so that will be opposite over adjacent. So it's always going to be A over B. So in this case, we have 3 halves. In this case, we have opposite is 6, adjacent is 4. 6 fourths reduces to 3 halves. The next one, we have 1.5 divided by 1. Guess what? That is also 3 halves. The next one, we have 4.5 divided by 3, and guess what? That is also 3 halves. So it doesn't matter how big or small your triangle is. If they are similar, they're going to have the same ratio, okay? So that is why the unit circle is like a starting point, and then you can expand from there, all right? So just very quickly here, we have a summary of the 6 trigonometric functions. Sine will be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And that is where that famous acronym comes from, the right? However, that is not the name. The name is trigonometric functions. Okay? All right, so this is the end of the video. We'll finish this section Friday.